Afternoon, and thanks for joining me. I'm going to hopefully try to convince you at the end of this session that VMware has a new way of making it possible. The easiest and most efficient way to instantiate a private cloud using the software-defined data center architecture, and that we call EVO SDDC or EVO software-defined data center. I want to start with a required disclaimer. This product is still under development. We have launched it and will be soon making it available to the customers. The features and product is still under development, so no guarantees are implied or made here. So if you went to the keynote today, you saw that VMware has a vision of hybrid cloud and hybrid applications. That's a new world in which you write an application to run anywhere. It could be on-prem, off-prem, private cloud, public cloud. And you do that by creating an infrastructure underneath that allows you to write hybrid apps, including providing advanced networking services that allow you to seamlessly migrate between private cloud and public cloud. Underneath all of that, VMware has this vision of software-defined data center as architecture that allows you to bring together compute, storage, network virtualization, and all of the infrastructure management components together under one roof as a software-defined data center. That's the vision, and that's the march towards which VMware has been leading the customers to go and achieve the goal of creating this new hybrid world, including a very easy way to create on-prem private clouds. Now, but if you look at how to get to the private cloud, there are still different ways. There are debates about how to get there. The traditional approach is so-called hardware-defined approach based on proprietary hardware in which a lot of intelligence is based inside the hardware, and on top of that you lay out some software manually or many labor-intensive way, and you have to do manual operations. And that the enterprise IT finds very hard to deal with respect to the speed at which the lines of business are moving, and they are demanding the services be provided. On the other hand, the software-defined approach says, let's start with the industry standard x86-based hardware. On top of that, put all of the intelligence in software layer and automate the heck out of it so that you can create a really faster way to operate with respect to how you instantiate and operate your private clouds. If you achieve that goal, then IT also is able to move at the speed at which lines of business are demanding to grow. Despite this vision of software-defined data center, people have not found it easier to actually build, instantiate, deploy, manage, and operate a software-defined data center. And the challenges are on multiple sides. The first one is upfront setup. If you are an IT manager trying to do software-defined data center, the first question comes is, where do I begin? You need to have some kind of a way to start with a reference architecture. The reference architecture now is being provided by VMware in the form of what we call VMware validated reference designs. But more importantly, before you even start looking at the reference architecture, you have to look at the current organizational structures and policies that IT already has. A typical enterprise IT is organized into silos of security, storage, network, compute, and so on. All of those have their own policies, all of them have their own rules. And when you talk about software-defined data center, you are trying to bring all of those under one roof, which means you have to start breaking the silos. Then you take the reference architecture. Based on the reference architecture, you still need to build the whole infrastructure, which means you have to procure components from different vendors. You have to figure out how to integrate them. So you have to invest a lot of time before this stuff can be brought up. The bring up itself is challenging because now you have disparate pieces of infrastructure coming from different vendors that have to be integrated together, installed, configured, and so on. And most of these come with lack of automation or tools to make it easier to instantiate and provision this infrastructure. There are also many points of control because all of the vendors have their own management console, management tools to manage their part of the infrastructure, be it networking, storage, or compute. So now you have to deal with many tools and many points of control. And finally, the biggest headache that enterprise IT has is lifecycle management. All of these components, when they are brought together, have hardware components, firmware, BIOS, drivers, the VMware stack, including hypervisor, vSphere, management infrastructure, and so on. All of those different vendors are putting out patches at different rates. Maybe those are critical patches because things don't work, or there are periodic updates to the features. And all of that lifecycle management has to be done manually, and when you patch and update one piece, you might break something else. So this is another complexity that's added in terms of how you operate a software-defined data center. Recently, I think if you look at last few years, people have introduced what is known as hyper-converged infrastructure, which means that you take a standard Intel x86 server platform, put a hypervisor on it, and use hypervisor to provide both compute and storage virtualization integrated using servers which have directly attached storage or JBOD storage. Advantage of doing that is that you get full product level integration. Hypervisor itself has a kernel level module to do storage virtualization apart from compute virtualization. You get simplicity because you get unified management. For example, vCenter now can be used to manage both storage and compute together, and you can apply policy-based automation to that. We have contracted with a third-party independent firm to do the TCO analysis and found that you can save up to 50% in total cost of operations. Not just upfront cost because you're getting standard servers with directly attached storage, but in terms of day-to-day operations also, this leads to simplification of operations. And of course, you have performance. With virtual storage based on hypervisor like vSAN, you can get up to 7 million IOPS. Depending on the how many SSDs versus hard drives you use. And you also find that this is a very easy structure to scale out because based on very elastic architecture, you have rack mounted servers with directly attached storage. You can scale out by adding server and storage. And finally, VMware makes it easier to provide support different deployment models because we have a notion of vSAN ready nodes which are pre-qualified by VMware, and multiple vendors can provide now hyper-converged infrastructure nodes which can be integrated into this environment. So going from build your own hardware-defined approach or starting with the reference architecture in which you have to procure from different vendors and try to deal with multiple management tools, the hyper-converged infrastructure takes one step forward. It makes it easier because it brings together compute and storage. And data is sitting right next to compute, is directly attached storage, so you don't have to go across the SAN, so you also reduce latency, get better performance and so on. So that's definitely a step forward. But if you look at this axis, what IT is looking at is higher agility. IT is under pressure from internal lines of businesses or customers because they look at outside public clouds where you can bring up a VM in a matter of minutes by putting in a credit card, versus IT taking a lot of time to bring up the infrastructure. So they want higher agility. They also want low risk because operational costs have to go down. IT is under continuous pressure to reduce cost, and comparison with public cloud doesn't help. So across these two axes, if you just look at the traditional approach, build your own, that's really lower agility and higher risk with respect to deployment of operations. Hyper-converged infrastructure takes you further. It starts making it easier to deploy. Operations are easier and also starts providing you higher agility with respect to bringing up provisioning, storage and compute. With EVO SDDC, which is what I'm talking about today, we plan to make it even easier. We want to take it to the rightmost quadrant, uppermost quadrant, so that you get higher agility as well as lowest risk by simplifying all the parts of the infrastructure. And that's what I'm going to talk about today. So what is EVO SDDC? As I said earlier, we want to bring together compute, storage and network virtualization together in one place, add to that the management which is required for managing this virtualized infrastructure, and combine all that together using a new piece of software. We're calling it VMware EVO SDDC Manager, which is a distributed management system which is designed to be a cloud infrastructure manager across all of these components to provide a single pane of interface for managing physical and virtual infrastructure. So what you get out of that, you get lots of simplicity because you are not investing in multiple tools, multiple points of control. You get agility because everything is virtualized based on industry x86 based hypervisor like ESX and vSAN and NSX. And you can also start applying policies for availability and so on at data center scale using EVO SDDC Manager. So just to conceptually, what happens is when you have the VMware EVO SDDC Manager, what you are getting is an integrated system, integrated solution which can consist of one or more racks. They're interconnected using a leaf-spine network topology. So all of the traffic that goes between these racks east-west traffic stays within that private cloud instance, and all of this can be operated as a single infrastructure. And more importantly, we do this based on some pre-imaging, pre-install, pre-configuration, so you can bring up the software-defined data center in about 2 hours or less. So you can now avoid all the problems I mentioned with respect to starting with a reference architecture, dealing with multiple vendors, configuring it yourself, doing all the manual operations. Instead, EVO SDDC Manager and EVO SDDC Manager powered integrated solution is designed to make it easier for you to bring together a software-defined data center in 2 hours or so. So that's the biggest value proposition when it comes to the bring up part of the deployment. What do you get out of such infrastructure? You get a very scale out kind of a model. You can start at very small infrastructure like 8 nodes, server nodes with some switches, and incrementally add 1 server at a time to scale out. And in a rack full of servers, assuming there are 24 nodes, we assume 24 server, 2 socket servers in a rack, because most of the enterprise IT is limited by amount of power they can supply to one rack to about 12.5 to 13 kilowatts. Within that power envelope, we can support 24 servers plus switches. With that kind of infrastructure, you can do infrastructure as a service and VDI concurrently in the same infrastructure. If you're just doing infrastructure as a service, you can support up to 1,000 VMs, assuming each VM has about 2 vCPUs, 8 gigabytes of memory, and about 90 gigabytes of disk storage. If you're doing virtual desktops only, you can do about 2,000 VDIs, assuming about 1 vCPU, 4 gigabytes of memory, about 45 gigabytes of disk storage. And in overall, using vSAN, you can get more than 2 million IOPS, at least 2 million IOPS using a 10% SSD cache to hard drive ratio, or more million IOPS if you have more SSDs. And you can go to all flash version also. So that's what you get out of this. At this point, I would like to invite my colleague Anil Kapoor, who is a senior product line manager for this product, to do a demo of what do you do in terms of bring up with using this particular infrastructure.
Thanks, Raj. I'm really excited to be here today to talk to you about EVO SDDC, the easiest way to SDDC. When we talk to customers about deploying an integrated system like EVO SDDC, they really worry about 2 things. First, how do I integrate this rack into my existing data center? Number 2, they wonder about how do I construct a common set of management services that I can use across all of those racks. And with our demo today, we're going to show you exactly that. Now, first I want you to close your eyes and imagine. Imagine that you've purchased an EVO SDDC integrated system, and it's arrived, you've plugged in the power and the cables from the top of rack to your existing core networking. What you'll see here is the setup screen. And the first thing we'll do is insert the general information, configuration information, for our first rack in our EVO SDDC scale-out integrated system architecture. We're going to build that management services, configure that management services first. And really that's a management cluster that will contain a number of common services. To do that, we'll need to specify networking around management cluster networking, vMotion, vSAN, and VXLAN. But this management cluster doesn't exist in an island. It needs to integrate with the rest of your data center. And to do that, we have to specify external IP addresses, gateways, and DNS. We review what we've just inserted, hit connect, and what you'll see here is a series of services that will be applied those external IP addresses to, including Log Insight and vRelay's operations for logging, capacity management, and analytics, NSX for virtual networking, vCenter, which will serve as the vCenter, the foundational vCenter of our management cluster, the PSC for single sign-on capabilities, and our new EVO SDDC Manager, the single pane of glass for both physical and logical configuration. We hit confirm, and that's it. Go to lunch, come back a couple of hours later, and what we'll do in that time period is configure the top of rack switching and spine switches. We'll build out a management cluster, populate it with hosts, and build out those services I just showed you. automatically. But once we have this first management cluster, Raj, what can we do with it?
That's next. Thank you. Thank you, Adi. So I think what you saw just now is that how do you bring up the entire infrastructure, what you do on the day 0 with respect to collecting information from the administrator about your network information, all the other things you need to do. And next step is now you start using it to deploy VMs and workloads and so on. So here, as part of this process, what we're doing is that once you have brought up and done the management cluster and brought up the entire infrastructure, what you're getting is a new abstraction called virtual rack. No matter whether you have a single rack or multiple racks, you get a pool of resources, compute, storage, networking in the form of virtual rack, in which you do not have to worry about where they are placed, what they're running, because all hardware is abstracted out. And looking at the virtual rack, you decide now to carve out the capacity into different what we call workload domain. That's a new abstraction using which you can take the same capacity and say, I'm concurrently going to run different types of workloads. I'm going to carve out capacity for infrastructure as a service, big data, or VDI. And each workload domain has its own policies about capacity, availability, security, performance, and so on. And those are taken care of in terms of translating those into actual allocation of resources from one or more racks is taken care of by the EVO SDDC manager. So using a few clicks now, you can create a workload domain in which you can now start deploying VMs and bring your either create VMs or migrate VMs, bring in new workloads, and underneath workload domain will provide you the necessary performance, availability, and so on that you specified. Underneath the curtain, the EVO SDDC manager takes care of allocating resources, host, creating vCenter clusters using vCenter APIs, and so on. So that you do not have to manually create all those things that you do normally. Once you have created these workload domains and carved out capacity, you have NSX, which provides microsegmentation. Using that now, you can start protecting each workload domain from other by deploying firewall rules and policies using microsegmentation. Moreover, within a workload domain itself, you can have per VM security policies. So you can protect VMs from each other using firewall rules and policies, again using the NSX microsegmentation, which is again automated, so it's easier to do, and you do not have to invest in a separate physical appliance for firewalls and so on. So that's other advantage we bring in by integrating NSX. So Anil, can you show them how to bring up the workload domains?
Yeah, absolutely. So Raj, actually one question that customers always bring up is, why do I need another manager or managers? I mean, aren't managers just overhead? I mean, no offense.
That's a different conversation I want to have with you. I happen to be his manager, so next review I should definitely address that, whether I'm needed or not. But I think going back to the question which is relevant, do we need yet another administrator or manager? So the vision here is that EVO SDDC manager is not a manager of manager. It's really a cloud infrastructure manager, which goes across all of the components and including the network, compute, storage, virtualization, other management components like realize operations, login set that you needed for capacity management, event, alert management, and so on, but provides you a single place from which you can manage both physical infrastructure and virtual infrastructure, and do not have to invest in multiple tools. That's the vision.
I see.
So that's why you need me too.
Okay, makes sense. I need that vision, Raj. So first thing we'll see here is the EVO SDDC manager. And when we talk to customers about provisioning out that infrastructure, that first set of infrastructure, there's really three things that they're worried about. First, they're worried about how do I easily provision capacity? Number two, they're concerned about availability and how do I set those availability parameters? And then number three, performance parameters. How do I set those performance parameters as well? And that's all done here through the EVO SDDC Manager UI. It's beautifully simple and focused on exactly what we need to do, which is building out those private clouds. The functions include roles and permissions, eventing for both logical and physical infrastructure, lifecycle management, as well as the ability to manually reconfigure what we've automatically configured on your behalf. There's really two classes of workload domains today. First is VDI, and the other is infrastructure as a service. and that's just for now. The future will bring more. So today we're going to build, let's say for our mobility application, a new infrastructure as a service. We're going to specify its name. The thing I'll point out here is that this single pane of glass has all the capacity of your data center. Due to the EVO SDDC scale-out architecture, the EVO SDDC manager is able to manage all of that physical infrastructure from a single pane of glass, upon which you can carve out CPU, memory, and storage. We hit next, and the next thing that the customers want to be able to solve for is performance parameters. We've simplified all of those SDDC performance parameters to just 3: development, staging, and production. Today we'll choose production. And that means more than just turning on DRS for compute and memory. It also means that we're going to set the vSAN stripes for storage policy and NIOC settings to set your networking performance policy as well. This is all done by VMware experts who keep your infrastructure up to date as new releases of that SDDC are put out and new features become available. Those experts fold in those best practice recommendations into this simplified UI and policy selection. It also includes availability parameters. Again, low, normal, and high for the SDDC parameters. Today we'll choose high, and again, that's more than just turning on vSphere HA, setting the number of replicas for vSAN as an example. We'll hit next, and again, for this new set, this new vCenter and host that we've populated, we'll need to be able to configure management, vMotion, vSAN, and VXLAN. But this infrastructure as a service, this vCenter with its host, needs to be able to communicate with the rest of the data center. So we also specify external IP address. We hit next, and when we hit finish here, what's going to happen is we're going to build out a vCenter, we're going to populate it with hosts based on those policy settings that we just went through, and that vCenter will be put into a management cluster and tied into all the common services that we described earlier, including VROPS, Log Insight, NSX, etc. And with that, you have your infrastructure as a service. But now that we've built that, how do you keep it up to date and secure? Because otherwise, it'll feel just as insecure as I feel about my job right now, frankly. Raj, what do we do? What do we do about that?
First, you better feel insecure about your job. Because I do want to show the value of the manager here. So I think he's right, that one of the other questions that comes up is that what do you do about the lifecycle management? How do you keep such an infrastructure up to date? So what we have done is, as part of the EVO SDDC manager, we also integrate the function of automated lifecycle management. That lifecycle management starts at both hardware-related components such as firmware, BIOS, drivers, the switch operating system, because you have operating system running on switches, and also entire VMware stack starting with the hypervisor ESX all the way to vSphere, the vRealize components, as well as EVO SDDC manager. All of them need to be done in a way that you could do in a non-disruptive way. If you have a spare capacity, you can afford to migrate the loads also. So that's another feature of EVO SDDC manager integrated into the infrastructure to make it easier to do lifecycle automation. So far what I've talked about is we started with the vision of these hybrid apps that can run anywhere, that require both private clouds on-prem as well as off-prem. Software-defined data center is an architecture for creating such clouds, and EVO SDDC is our offering in partnership with hardware partners, in which we integrate something called EVO SDDC manager along with all the compute storage and network virtualization components and all the hardware components to provide an integrated solution that can deliver the simplicity with respect to how you procure, build, install, manage, and operate a software-defined data center. You saw as part of that, we talked about how the bring-up is made easier, as well as in terms of operational simplicity, we provide an abstraction called workload domain that allows you to carve out capacity to concurrently run multiple kinds of workloads with different performance availability characteristics, including infrastructure as a service and virtual desktops. Now, what I'm going to do is walk through some of the more details of the software-defined data center. So first of all, as I said, our goal is that in working with our hardware partners, we want to be able to provide an integrated system powered by EVO SDDC. That will have following key components. All the VMware components are listed here. They start with vSphere Enterprise Plus, vSAN, NSX, login site, operations management, vRealize operations management, as well as two optional components. You can do vRealize automation, or you can do Horizon View, or both. Horizon View is necessary if you're going to do virtual desktops. We automate the entire installation and configuration of the Horizon View infrastructure. You have the EVO SDDC Manager, which is the single interface, either programmatically or manually, like Anil showed, using the UI to be able to operate and manage this software-defined data center. We have another abstraction called Hardware Management Services that allows you to add to this different hardware components that our partners provide, including management switch, top-of-the-rack switches, spine switches, servers with directly attached storage, and PDUs, kind of auxiliary devices. What our partners will do is they'll take all of this, integrate them together, and deliver a solution that consists of SDDC software, the physical hardware, which is fully pre-racked and pre-cabled. So idea is to do all of the integration in the factory by the partner, including pre-imaging, pre-installation, pre-configuration of all of the hardware and software components, and have a EVO SDDC Manager bundled together as a centralized operations management tool to manage all of this infrastructure together. Just to recap what happens with respect to how you order and use this particular system, on the left-hand side we show what our hardware partners do. So typically, as part of the ordering process, we'll do a site survey. In site survey, we'll find out what your requirements are in terms of racking, cabling, and so on, including the physical network connectivity to the corporate network, because every customer's corporate network environment tends to be slightly different. They have either L2 connectivity to the rest of the network or L3 connectivity. They may have a Cisco gear, Juniper, Brocade, different types of switch vendors. We have to be able to integrate with them right on day zero. So we do site survey, and based on capacity requirements that user has, the customer has, we create a software hardware manifest that we give it to our partners. Partners take that manifest, and they first of all assemble the entire hardware in factory, one or more racks, including switches, servers, storage, and so on. We also provide partners an appliance called VMware Imaging Appliance. You connect that to the rack. Its job is to image the entire rack with firmware, BIOS, drivers, our software stack, switch software, and so on. After that, they run a pre-validation test, and after the pre-validation test runs, it's all ready, cabled together. Entire rack is cabled with connectivity provided for external connectivity to power and networking. It gets shipped to the customer. On day zero, customer receives it. They can connect it to the network and power, bring it up. First thing is our hardware management service comes up. It auto discovers the entire inventory, validates it against what was expected to be brought in. There might be some DOA components that have to be disregarded, and it builds the entire physical inventory. And after that, our EVO SDDC Manager comes up, and it will start allocating resources and so on, creating the management cluster and so on. At the end of the creating the management cluster operation that Anil described, you have the EVO SDDC ready for operation. So it's that easy. The entire process on the right-hand side takes a couple of hours. So in terms of EVO SDDC Manager's function in this process, the first thing, as I said, is the fully assembled rack arrives. It gets cabled up, connected. On power on, we do inventory validation. We bring in the hardware management service and EVO SDDC Manager. We check a system against all the good inventory. All the DOAs and others are removed from. You provide that information to the customer so they can be replaced. Customer information input is taken. So all the information about your networking input, network connectivity for management, vMotion, all the VLANs information, port groups, all of that information can be obtained. IP address ranges. In that case, what happens is after we take the input, we do the second boot. During the second boot, we re-IP the entire infrastructure. So you have the right valid IP addresses for externally facing, corporate facing components. And then we create the management cluster, which has EVO SDDC Manager. It runs all the management components like vCenter that are needed, NSX Manager, NSX Controller. We create the vSAN data store. We configure vRealize products. All the management packs, if they are optionally included for the customer, they are installed and configured. And also we make sure that the management cluster that runs all of this infrastructure is configured for high availability. And finally, I think customer is able to create workload domains and start creating VMs or migrating VMs. I talked about workload domains. Just to go into some more details, workload domains require you to specify requirements either using API or UI, which include what kind of workload you have, and you provide information such as capacity, performance, availability that gets translated into CPU, memory, storage, and networking requirements, storage policies, device selection, as well as some of the workload placement strategies will be derived from the availability requirements. For example, if you're N+1 versus N+2, you may have to allocate a host in a cluster from a different fault domains. So what the EVO SDDC manager does is, as part of this process, it creates the ASX cluster, configures it for the necessary availability. It will create the vCenter for that workload domain. As part of that, it will configure the cluster into vCenter. It will do the physical configuration of the network as well as logical configuration for VLAN and VXLANs. It will bring up the distributed virtual switch, NSX manager and controllers for that. vSAN disk groups, data stores based on performance and availability policies supplied, and finally configure the vRealize components for use with that workload domain. All of that is done so that now you have ready to go workload domain in which you can deploy virtual desktops or VMs for infrastructure as a service. I talked about lifecycle management. I want to give you some more details of that. As I said, this is the most complex process in any environment, because now what you've done in the EVO SDDC, you have all of the hardware related components like firmware, BIOS, drivers, you have switch operating system, all of the VMware stack, including EVO SDDC manager. Our model is that we want to automate when and how you do this upgrade management or lifecycle management. And it works in the following way, that all of the software versions that are including firmware BIOS, we have a very prescriptive configuration. We pre-specify it. So we know exactly in each customer installation using phone home capability what configuration they are running. We have predefined software bundle, and for every update or patching, we create software bundles. Low-level bundle could be for firmware BIOS, ESX vSphere bundle, vRealize bundle, NSX bundle, or EVO SDDC bundle. That bundle has the necessary components for either patching or updating from the previous version. And these are all pre-validated and integration tested for interoperability, because most of the time the problem is you apply patches or updates and something breaks in terms of interoperability. So we want to do the integration testing in the lab before we surface those bundles in the EVO SDDC manager at a customer location. And this will be published by us. So under this model, the customers do not go and willy-nilly get patches and upgrades from either third-party vendors or VMware and try to manually apply them. TakeOps doesn't walk up to a rack and say, let me update the firmware or patch the update. That will not work. Instead, we control the whole process because we have predefined bundles. We surface those, and there are two models for this. One is what we call quarterly train model. Every quarter, we'll publish these bundles, which are available, which will combine the patches and updates available in the last quarter. These are pre-integrated, tested for integration and interoperability. They are available to you, and you get to decide when to apply them, where to apply them. For example, you might say, I want to apply this low-level bundle only to this workload domain, but not to that workload domain, because first I want to try out lifecycle management or updates for this dev test workload domain, but not the production workloads. You can do that. You can specify when to do that, at 2 a.m. next day. And EVO SDDC manager will take care of applying those update bundles you chose to that part of the infrastructure first, and including our providing rollback opportunity if things break. But that's not enough, because that's a quarterly sort of a discipline of applying updates or patches. And that's not going to be sufficient if you have some critical updates from a firmware vendor, or suppose a desk controller has a big bug, or there's a critical security bug, a security problem like shell shock or heartbleed. People want to immediately apply those updates. So for that, we have asynchronous update bundle. Once such a update is available, either from VMware or third party, we'll again create a bundle, pre-test it for integration and interoperability, and we'll publish it, and you get to apply. So by doing so, you do lose some flexibility because we are now controlling the process, but we hope to provide more ease of operation because instead of applying manually these patches and updates and breaking things, we will guarantee there's interoperability and things are applied in an automated fashion. That should reduce a lot of the operational complexity that the customers face today. So far, I have talked about EVO SDDC as in an abstract without talking about the physical hardware. So in a physical configuration, I would like to show an example of a configuration that you see. So assuming about 12.5, 13 kilowatt power per rack, we believe that we can have 24 Haswell class 2-socket servers, which is about 48 nodes, with about 10 drives and 2 SSDs per server. You get about 500 terabytes of raw storage, 384 gigabytes of memory. Again, these are configurable in the sense that you get to choose the number of cores or amount of memory, amount of storage up to limited range, not any arbitrary combination, because we do pre-qualify some of the server models and so on. But you do get some variation. Then each rack has 2 top-of-the-rack switches. So each server is connected to 2 separate switches for redundancy. 10 gig NICs are included in each server. They're connected to separate TORs. We also have a per rack management switch, gigabit Ethernet management switch, connected to all of the BMCs and other switches for out-of-band management. And this network is basically non-routable IP private network that runs from the management switch. And finally, for inter-rack connectivity, if you have multi-rack configuration, we have 2 spine switches, which are 32-port, 40 gig spine switches. In case of top-of-the-rack switches, these are 10 gigabit Ethernet switches, 48 ports, but they also have up to 4 40 gig Ethernet uplinks for corporate connectivity. So what you get out of that is the pre-racked and pre-cabled, pre-installed hardware with built-in PDUs. You have drops for power and network included, everything else is cabled, and you get to choose the number of CPU cores, memory, and storage. That's a variability. In terms of the network deployment model, let's start with a single rack. In the case of single rack, as I said, you have a bunch of servers that are connected to separately to 2 top-of-the-rack switches. There's a separate 1 gig management switch that's connected to the BMCs as well as to top-of-the-rack switches for out-of-band management. And corporate connectivity is from the top-of-the-rack switches using 40 gig links. And that's again redundant. You'll notice that the top-of-the-rack switches are also connected together using MLAG or link aggregation so that you get redundancy between them. So this is what the single rack connectivity looks like. So you integrate to an existing data center network either using layer 2 connectivity, using VLANs, or layer 3 connectivity. In that case, we assume OSPF or BGP interoperability with an existing corporate router. We want to make sure there's compatible with existing switches from other vendors so that we don't break any interoperability. Mention layer 3 or layer 2 connectivity, and you use the same network management tools. You do not have to invest in separate management tools because EVO SDDC Manager allows you to also do network management for the switches.
Sorry, where does the edge device fit in here?
Edge cluster, you mean? So in the case of NSX, unless the multi-rack, we don't separately call out the NSX edge cluster. Instead, you'll do the configuration of NSX in the first rack itself. But if you have more than 2 racks, then it makes sense to have a separate NSX edge cluster. In the case of multiple racks, you have multiple racks, and as I said earlier, that they have redundant connection to spine switches. These are 40 gig spine switches. This is how you control all the east-west traffic. All the east-west traffic stays within this private cloud, and the corporate connectivity is from the first rack top-of-the-rack switches using 40 gig connectivity. So in terms of creating a self-contained private cloud, this controls the amount of traffic you have. Now, in terms of the architecture, this basically shows you the software architecture. At the bottom, you have the hardware components. You have the data plane components like vSphere, NSX, vSAN. Then associated management components, NSX Manager and vCenter. Operations and management components from VMware, including optionally vRealize Automation and Horizon View. In the case of Horizon View is needed, which have VDI workloads. Then we have our EVO SDDC Manager, which you can access in 2 ways. You have this user interface that Anil showed you, so you can operate it that way. or you have REST APIs for programmatic connection. So if you have an existing backup solution, you have data center infrastructure management tools you are using, or BMC like monitoring tool, you can integrate those using the REST APIs. At the bottom, you have the hardware management services. That's our abstraction layer that makes sure that all of the software, EVO SDDC Manager, runs in the hardware agnostic or vendor agnostic way by supporting multiple vendors. Just to give more details of hardware management services, it's basically an abstraction layer. So if you look at it here, that hardware management services runs on top of the management switch. It's in a Java environment. It's responsible for discovering the hardware, monitoring it, receiving alerts and events, coalescing them, setting thresholds and stuff like that. And also it's responsible for low-level firmware upgrades. If you look at inside the hardware management service, we have created a hardware management API, which is our layer to abstract out hardware, below which you see different vendors can put in plugins for their hardware specific plugins that we jointly develop. We provide an SDK for the partners to develop those. So IPMI plugin, OEM plugin, white box vendor plugin like Quantas plugins, or OCP, Open Compute Platform plugins. But what you do on top of the hardware management API, we create objects called, these are abstract objects, server, switch, storage, or auxiliary devices like PDUs. All of the operations are performed on these abstract objects. You don't have to worry about the hardware specific things. Okay, we do the translation using those plugins. And hardware management service to the rest of the infrastructure provides physical inventory in a vendor agnostic way. Then the EVO SDDC Manager, just to summarize, is the one which is responsible for bringing up and managing all of the infrastructure. It's a cloud administration interface basically. It really reduces the amount of time it takes to bring up the whole infrastructure. But more importantly, it automates a lot of the operations such as creating vCenter clusters, receiving alerts and events, managing the physical infrastructure without investing in a separate management tool, and provides a centralized management and integrated view of both physical capacity and virtual capacity that you can manage. It also makes sure that we have pre-tested for interoperability and automate the lifecycle management of both hardware and software related components. And finally, I think using the workload domain abstraction, we provide an optimized way of translating policies for capacity, performance, availability, and security into underlying clusters and how they are configured for high availability, how the physical resources are allocated, network quality of service is provided, and so on. So to summarize, what we started out talking about hybrid apps, they're designed to run anywhere, including off-prem and on-prem clouds. EVO SDDC is our way of providing an easiest way and most efficient way to bring up private cloud instances using software-defined data center architecture from VMware. And the integrated systems are provided by our partners working with us, which will integrate both hardware and software. These things are pre-integrated and pre-tested on selected pre-qualified hardware and software bill of materials, including allowing you to provide, giving you some flexibility with respect to choosing the kind of number of CPU cores, memory, storage, with respect to across multiple vendors, but these are pre-qualified and pre-tested. Our partners, as I said earlier, will take our EVO SDDC software, integrate that with their hardware, and do the factory integration process for pre-imaging, pre-install, pre-configure to deliver this is the integrated solution. And we are launching this product at VMworld, and it's going to be available soon for limited availability from some selected partners. With that, I want to point you to some other sessions coming up. There are 2 sessions on Thursday at noon. One of them is a deeper dive, which goes into more details of some of the functionality of the EVO SDDC Manager, workload domains, and so on. And there's another session devoted to network integration, NSX integration. We also have had a session today, yesterday rather, on putting EVO SDDC to work across the company. And that session you can access across the using the YouTube channel. That's an interesting one because we have at VMware our own private cloud called OneCloud, which runs up to about 100,000 VMs. They have adopted this architecture and they are running production workload for virtual desktops using EVO SDDC. And that particular talk talks about their experience adopting this and what are the benefits they have found, which is our internal enterprise IT. So that could be another useful session for you. With that, I'm open to questions. Thank you.
Right.
Yeah.
You don't have the vRealize suite or NSX. Can you use this to manage your existing infrastructure?
Yeah, so the question is that can we use this with existing infrastructure if I have vRealize suite and all? So it depends on what you're trying to do. If you're talking about having existing vCenters to be migrate here, then we do allow you to migrate them. But if you want to take a current existing vCenter, point you to, you can take a vRealize automation that you have currently and point it to these vCenters to manage them. Yeah, that you can do that. You can create reservation points and point them to our vCenter. We allow you to do that.
Given that you're not doing software-defined networking, what happens to those VMs that are not covered by NSX?
No, the VMs that are deployed inside the EVO SDDC will always have NSX. That you don't get to choose. Yeah.
Does SDDC have some limitations in terms of scalability, like EVO-RAIL?
So in terms of scalability, we allow you to scale up to multiple racks. If you have a 32 port spines, because of redundant connections, you can go up to 8 racks. But if you're ready to invest in a more expensive 48 port or 64 port spines, you can expand to multiple racks. So architecturally, there is no limitation in terms of how many racks, but you'll have to invest in a bigger infrastructure, which is more expensive.
What is the customer doing with his existing licenses? You
Pardon?
said, yeah. What is the customer doing with his existing licenses?
Oh, so we do allow for fair value conversion. You do not have to buy new licenses. Instead, and our product marketing manager can give you more details, that we have a notion of doing fair value conversion for existing licenses. So you can apply existing licenses to this infrastructure, don't have to buy them again. That's a good question. Thank you. Yeah, go ahead.
My question is, we already have a VRA which works like a manager, okay, like a portal. Yeah. On top of that, now you're going to have this additional management layer. How does that differs from for any service you require a service management portal? Okay, so we are going to have as many management stack or portals one after other. So how does that?
So if I understand your question, that you use vRealize automation to create a self-service portal today. So what is this new management layer doing?
Because in context with any service management portal you still have.
Yeah. So I think EVO SDDC Manager does not replace the functionality of vRealize automation. If you have vRealize automation, you can still have self-service portal. But even with vRealize automation, somebody has to go and create the clusters, create the reservation points, and then connect them to the vRealize automation. That portion we automate using EVO SDDC Manager.
But it is on top of that abstraction.
You can say top or side, doesn't matter. But in
Okay.
terms of functionality, it is not replacing an existing functionality. It's augmenting the existing functionality with additional automation to simplify the operation.
Okay. And then the service management integration will happen from then this layer to service management.
Yeah, so we have REST APIs using which you can integrate your additional orchestration software. Yeah. Yeah.
EVO RAIL DAC is EVO SDDC.
EVO RAC was a code name for EVO SDDC. EVO RAC used to be the code name for EVO SDDC. That's a product. This is a private cloud data center scale solution. EVO RAIL is an appliance, 2U4 node appliance. It's not a private cloud instance.
So just to confirm, as long as the equipment's on the BOM list, Mr. Dell will build a rack for me with, say, Juniper switches in, is that?
That's right. Yeah. Yeah.
And making use of your existing hardware infrastructure?
Existing hardware infrastructure, unless it meets our bill of materials that we have pre-qualified, will not work, because then we cannot guarantee all this bring up automation and lifecycle management. Any other questions? Thank you. Thanks for joining us.